We have learned from the previous grades that there are two types of interest. We have simple interest and compound interest. Let me start with the simple interest. Simple interest is an interest that is based on the initial amount that is borrowed. Okay, so what happens is that you're borrowing 100 rands from someone or from the bank, and then when you return it back after a certain period of time, you are charged with an interest, maybe let's just say of 10% based on that amount that you borrowed. You see, so you're borrowing, back to the example, you're borrowing 100 rands, and then after a year you bring it back as 110 rand if the interest is 10%. You see, so this is based on the initial amount that you've borrowed. So the formula for simple interest would be, we have A, which is your final amount, is the same as P, which is your initial amount, into 1 plus NI. I is your interest, and then your N would be a period. You see, if this is based on yearly, this would be number of years. If this is based on month, this is gonna be number of months. Okay, so now taking it a step further, we have what we call a compound interest. So what happens is here is that you still have your principal amount, or the amount that is borrowed initially, but now here we're charging interest based on the balance at that time, not the amount that you've borrowed. So for example, if you're borrowing 100 rand again, and then you charge 10% per annum, okay, so now if you're borrowing it, let's just say for 2 years, right? So at the end of year 1, your final amount is gonna be the amount you have borrowed plus the 10%. So that's gonna be, if you borrowed 100 rands, that's gonna be 110, right? So now when you go to the second year, at the end of the second year, the interest is no longer based on what you initially borrowed, as explained in a simple interest scenario. In this case, your interest is going to be based on the amount that you're owing at that point, so which would be 110. So we're adding the interest there, so it's going to be adding 10% on top of that. That's going to be 121. You see, so in compound interest, you charge interest based on what you're owing, and then in simple interest, you are charged interest based on the amount that you borrowed, the initial amount that you borrowed. All right, so this concept of simple interest and compound interest is not only based on amount gaining interest. We can also apply this on depreciation, whereby you're buying an equipment, that could be a car, that could be anything that depreciates in value over time. So we can observe that in a simple interest scenario, again, we can have an equipment which loses value over time based on a simple interest formula. So what happens is that you're buying a car which loses 10% of its value every year. So in year 1, you bought it for 100 rands again. Okay, let me change my pen. You bought it for 100 rands at first, and then it loses 10% every year. So at the end of year 1, it's worth 90 rands. At the end of year 2, it's worth 80 rands. You see, so it loses 10% of its value, the initial value, every year. You see, so that's applying the concept of simple interest to depreciation. Again, we can have an equipment losing its value in what we call a reducing balance. So this is the same as on a compound interest. So what happens is that you have your equipment, which could be a car, again, could be anything that loses value. So that thing is losing value in a manner which, let's just say you bought it 100 rands, and then at the end of year 1, if the interest is compounded yearly, it loses 10%. Let's just work on 10%. So that's at the end of year 1, you're left with 90 rands. So at the end of year 2, so you're losing 10% of the remaining 90 rands, not of the initial amount, of the remaining 90 rands. You see, so going further and further, the interest is based on the outstanding amount, or the amount that's the balance at that time. So next, we're looking at what we call nominal interest and effective interest. So nominal interest is always based on yearly, it's always based on per annum. So your nominal interest is what we call your quoted interest. If you go to a bank and then ask for a loan, they're going to give you a quoted interest. They're going to say, we're giving you 10% per annum, right? So that's your nominal interest. So, but now that is not your actual interest for that particular loan. So now your actual interest would be what we call an effective interest. You see, so your effective interest takes account of all the compounding that would happen. If your interest is compounded yearly, in that case, if it's compounded yearly, your nominal interest is just going to be the same as the effective interest. But if it's compounded less than a year, maybe it's compounded quarterly, monthly, weekly, daily. So we need to take care of the compounding. So by doing that, we actually appreciating the fact that this interest is charged. If let's just say it was compounded on a monthly basis, we appreciating the fact that this interest is charged every month. You see, so if given a nominal interest, we can use this formula to find an effective interest. You see, so if we have, I'll just say 10% again, we have a nominal interest of 10%, which is what they are quoting us for a particular loan or a vehicle finance. You see, so now we can calculate the effective interest rate by using this formula, which is simply 1 plus, this is your nominal interest rate, and then this is over the compounding periods, number of compounding periods in that particular year, and then we raise all this to the power of those number of compounding periods and then minus 1. So this gives us the effective interest rate. Okay, lastly, I'm going to look at annuities. I'm going to start with the future value. So this is where, for example, you're putting every month, you're putting away the same amount of money. Maybe you're contributing 100 rands into an investment. That could be you saving for yourself, that could be a retirement, that could be, you see, you're putting money away from you into an investment. So what happens is that that money gains interest. You see, depending on the compounding. So this is different from what we've seen here, because here we're talking about just making one initial payment which gains interest over this period, but in this case we're putting money every single month and then it gains interest. Okay, so whenever you have a scenario where someone is putting a constant amount of money every month, and then with the hopes that it's gonna gain interest, and then they're gonna get a future value which is more than what they put in every month. Okay, so that scenario is a future value. So this can be calculated as the future value of that investment can be calculated in this way. So you have F, which is the future value, is equals to, we have your X, which is your monthly installment. If we're working on a monthly basis, this is your monthly installment, all into 1 plus I is the interest to the power of n minus 1, and then all over I. So take note of the compounding effect here, but you'll see as we go into the questions. Okay, so the last one, again, we have what we call a present value. So in a present value, think of a scenario where someone is asking money from the bank, or they are financing a car, or they are financing a house. You see, so you're taking a loan, you're receiving large amount of money from a bank or any financial institution, and then you're paying it back on a monthly basis. So your installment is based on the amount you've borrowed plus the interest that they're charging you. Okay, so now given that you're borrowing, I don't know, any amount, you're borrowing 20 rands, so we can calculate for 10 months, we can calculate how much should you pay back, so such that how much should you pay every month, such that at the end of 10 months you have already paid what you have borrowed and the interest that they have charged you. So by doing that, we can calculate the installment required given the amount of money you have borrowed. For example, if you are buying a car, you're financing a car, so we can have this amount. Maybe you're buying a 200,000 car, and then we know the interest that the bank has given you, okay, and then we know the amount of years that you want to pay the car, so we can calculate how much should you pay per month. That amount covers both the interest and the amount that you used to actually buy the car. All right, so I think we have covered the basics that we need to attempt the next questions. I know I haven't mentioned the sinking fund, but I think we've mentioned the basics that are enough for us to tackle a sinking fund questions. And then we're gonna see as we attempt these questions what how to apply all this. And then yeah, let's just jump right into it and see what can we achieve. Okay, our first question is as follows. We are told that Lebogang, a teacher at Soweto, invested 4,500 rands in a bank which pays an interest of 8.75% per annum, and that is compounded quarterly. She now has 13,500 rands in the account. How long did she invest the original amount in the account? Okay, so what we're getting from this statement is that we're dealing with compound interest, and then there's only one payment that has been made, and then we're given the interest rate, we've given the initial payment and the final payment. Okay, so let me just quickly highlight the important information. All right, so now we're looking for the duration for this investment. So the formula for compound interest single payment, as in our basics, is as follows. So we have our A, which is our final amount, is equivalent to P plus 1 plus I to the N. All right, so we have the final amount, which is the 13,500. We have the initial amount, which is 4,500. We have the I, which is the interest, 8.75 per annum compounded quarterly. Okay, so we're looking for the duration. All right, so substituting into the equation, the final amount would be 13,500, that's given, and then the initial amount, that's 4,500, and then 1 plus I. So our I is 8.75, and then that is compounded quarterly. So this means that this 8.75 per annum, it is paid up every quarter. So basically you can divide this by 4 to get a sense of how much is paid every quarter. So basically what I'm saying is that your interest is going to be 8.75 divided by 100. Remember, this is in percentage. So you can further, we need to divide this by 4. So I'll just put multiply by 4 here. This 4 just divides the whole thing by, this 4 just divides the whole interest, so that we split it as it's compounded quarterly. Okay, so now that's everything raised to the power of n. Okay, so the first thing we can do here is to divide both sides by 4,500. Okay, so now, because what we're trying to do is to isolate this n here, to find the value of this n. So the first thing to do would be 13,500 divided by 4,500. So basically what I did is 4,500, right? So that cancels out, and then we have 3 here, which is equivalent to 1 plus, and then we can find the value of that. That's 8.75 over 100 times 4. So that gives us 0.022, just to run it off, and then all that to the power of n. So this is 3 is equivalent to 1.022, all that to the power of n. So because we're looking for n, we can apply the log rule to this function, such that we know that the exponent would be equivalent to the log of your number, which is 3, divided by the log of your base, which is 1.022. Okay, so now that gives you that gives you 50.48, and then that would be obviously quarters. Yes, because we know, just to put this in years, because they didn't specify how we should put our duration, but we can divide this further by 4, because there are 4 quarters in a year, and then this gives us about, which is equivalent to 12.62 years, rounded off to about 13 years. Okay, so this is how we solve this question. So we could see that there's only one payment which was made into the bank, which is 4,500 rands, and then after some time it has grown to 13,500 rands, and then they give us an interest rate of 8.75 per annum, and then compounded quarterly. So meaning that the interest is paid up every quarter. So what we did is, using this formula for compound interest, what we did is we just put in what we're given, and then on the interest we divided it by 4, because we know it's been paid up quarterly. So that this interest is per annum as indicated, but it's paid up quarterly, so that's why we divided by 4. And then we're looking for the duration, because this is compounded quarterly and we're dividing it by 4 such that it's quarters. So whatever answer we're gonna get has to be in quarters, and then we converted it to years. You can even convert it to months depending on what they're saying they're looking for. In this case they didn't specify, but I just converted it to years. So that's how you solve such a question. Remember, they can bring it in any form. You can be looking for the final value, whereby you're given the initial value of the investment, you're given the interest and the duration, or you can be given the final value, initial value and the duration, and then you're asked to determine what interest yield that final value, provided that a certain initial value was invested. So this is how you solve this kind of a problem. Our next question is as follows. We are told that Mbali wants to buy a house in Pretoria for 700,000 rands. She pays a deposit of 20% and then takes a loan for the balance at a rate of 18% per annum, compounded monthly. Okay, so our first question, they're asking us how much money must Mbali borrow from the bank. Okay, so understanding the question, we are told that she wants to buy a house for 700,000 rands, and then she pays 20% of that as deposit, and then she takes a loan of the balance. Okay, and then the loan comes at 18% per annum, compounded monthly. So how much money must Mbali borrow from the bank? Okay, so to answer this, the total, which is 700,000 rands, is equal to the deposit plus the loan. Okay, so what happens is that we are told that she pays 20% deposit of the total amount. So she pays, that's 20% of 700,000 rands. Okay, and then the total is 700,000 rands. So now they're asking us how much is she borrowing from the bank. How much loan is she taking, in other words? So this is plus loan. So we can see that to find the loan amount, it's simply 700,000 minus 20% of 700,000. Okay, so that becomes 700, 123 minus 0.2 multiplied by 700, 123. So she's taking a loan of 560,000 rands. Okay, another easier way of doing this, we can simply say if she's paying a deposit of 20,000 rands, so surely she's taking loan for the remaining 80%. So now you can easily say the loan would be 80% multiplied by 700,000 rands. So that's 0.8 multiplied by 700, 123. So that's 560. Okay, easy as that. There are two approaches. You can take either one. This is the quicker one, but this one has some sort of understanding integrated in it. But either one works to the same amount. Okay, great. Okay, so question B says calculate the monthly payment if he, or rather if she, wishes to settle the loan in 15 years. Okay, so remember they gave us, we know from the previous question that she's financing 560, 1, 2, 3, okay, 560,000, and then that's the interest that she's given. Okay, so we need to calculate the monthly payment. Okay, so we know that this is a present value annuity, right? Because someone borrows money and then they get money at that instant, huge amount of money at that instant. So it's a present value. All right, so from our basics, we know that our present value is calculated as follows. We have 1 minus 1 plus I to the minus n. Okay, and then this is all over I. All right, so this is the present value. That's the amount of loan or financing that she's borrowing, and then that's the monthly installment, that's the interest, and then that's the duration. In this case, is it going to be years? Is it going to be months or quarters? So how do we answer that question? We look at what the interest is compounded at. It's compounded monthly, so this has to be number of months. All right, again, even the interest, we need to divide it by 12 because this is 18% per year. So, and then if it's compounded monthly, how many months do we have in a year? We have 12. Okay, but proceeding with the question, so we're gonna have 560,000, and then we're looking for the installment, and that's 1 minus 1 plus our I, which is going to be 18% divided by 100, and then multiply by 12. Right, this multiply by 12, I'm simply dividing the whole thing by 12 to change it to month. So that's to the power minus n. So your n would be 15 years by 12, so that's 180 months. Okay, so it's like that, and then all over our I. So our I is still 18 over 100 multiplied by 12. The 12 divides the whole I, right? The 100 change it because it's percentage. Okay, so we can we've substituted, so we can simply start working it out, and then we can first cross multiply, right, to get rid of the fraction. I like getting rid of the fraction, so I'm multiplying this by that and then this by this whole thing. So that's 560, 1, 2, 3, multiplied by 18 over 100 multiplied by 12. So I get 8,400 this side. So that's equivalent, because this is just 1, it's equivalent to x, but what is this thing here? So that's 1 minus bracket 1 plus 18 over 100 multiplied by 12 to the power minus 180. So this whole thing gives us 0.931. Okay, so our monthly installment would be 8400 divided by 0.931. So we're getting 9,022 rands, and then that goes with 56 cents. That's our monthly installment. That's what Bali needs to pay every month to pay off her beautiful townhouse in Pretoria for the next 15 years. Okay, so that's that. So she paid a deposit of 20%. Obviously, had she not paid the deposit, this would have been greater because she would have financed more money than she actually has now. All right, so that's that. I hope you guys can understand what happened here. It's quite straightforward. If you got the initial amount that she's financing, then the rest is just putting in. And then one thing that could confuse you, but as I've mentioned, if your interest is compounded monthly like that, this has to be number of months. Okay, so that's that. Okay, our last question from Mbali is as follows. Mbali wins a lottery and wishes to settle the loan after the 50th payment. Calculate the outstanding balance. Okay, so we know that she's been paying. In our previous question, we found 9,022. I've actually reworked on that problem, and then there was a bit of rounding off that was not done properly. So the correct answer would be 9,018.36. Okay. So we got, let me just put that in brackets, 9,022. All right, so let's just continue working with this one. So this is what she was paying every single month. Okay, so now that she has won the lottery, after the 50th payment, she wants to settle the outstanding balance or the loan. Okay, so now we need to calculate how much does she need to settle. What's the settlement fee? Okay, so now a way of doing this is you're looking at two things, because there are two sort of transfers of money. There's a bank giving you money at an interest, there's you giving the bank money. So a way of looking at it is like this. So first of all, think of it as a bank invests in you or in Bali. Okay, so they investing 560,000 at that interest, 18% per annum, compounded monthly. Okay, and then they invest in that for 50 months. Right, the 50 months comes from after the 50th payment. Okay, so the banks invest that in you. Okay, and then the other side of the coin looks like this. So you're investing every single month. So you or Mbali invests in the bank. Okay, so but how much is she investing in the bank? So that's 9,018.36 times 50. This is 50 times, right? Or 50 months. At what interest? At 18% per annum, compounded monthly. Okay, so same interest rate. All right, so now to find the balance we look at it this way. So since we're thinking of it like the bank invested in you, so remember, so now thinking about this, that would be just one payment. They just paid you 560,000. So we can now calculate how much interest have they accumulated, or rather what is the amount after 15 months. So this is simply done like this. So we're gonna have the investing 560, 1 2 3, that's 1 plus 18 over 100 multiplied by 12 all to the power of 50. So that's 560, 1 plus 18. Okay, so we're getting the total of 1,178,935.76 rands. Okay, so think of it this way. If you're not paying any installment, the bank just gave you that 560,000, and then you spent it doing whatever that you're doing, or rather maybe bought a house. So this is what you would be owing the bank if you were not paying any installment. Like, they just gave you the money and then you were not paying anything. Obviously they are charging you interest, so this is, we'll be owing 1.1 million rands basically. Okay, and now on the other side, we're saying, now if you alone have been paying this amount to the bank at the same interest for same amount of time, how much would you have in the bank if you were paying this amount? So now looking at this, this is future value annuities. So we're gonna say this is future value because you're paying every month, and then we want to know in the future how much would that be worth. So that's x, and that's 1 plus I to the n minus 1 all over I. All right, so now your x is 9018.36, and then 1 plus, that's 18 over 100 by 12 all to the power of 50 minus 1, and then you divide everything by 18 over 100 by 12, and then you're gonna get the amount. So that's what these payments for 50 months at this interest would be worth. So let's just quickly find that out. So that's 9018.36 into 1 plus 18 over 100 times 12. Okay, that to the power of 50, and then minus 1. And then divide everything by 18 over 100 multiplied by 12. So I'm getting 6. I'm getting 6 and 6 4 4 98.26. all right, so basically this is, let me write it properly. So this is 664,000 and then 498.26 cents. So now we have two sides of the coin. If the bank was investing, they just gave you 506,000, and then after 15 months, this is how much you'll be owing them. And again, if you alone have been paying this installment of 9,018 rands, and then you're paying that for 15 months at the same interest rate, this is how much that would be worth. So now the balance would be obviously the difference between this. So the balance would be this amount, 78,935.76 minus 664 and 498.26, and then that gives us let me quickly and then that gives us a balance of 514, and for 514,000 and 437 rands 49 cents. So that's the balance. So that's what Mbali would have to pay at the end of the 50th payment. Okay, so let's just recap on what we did. It's not a tricky question. To find a balance of a loan at any given point, you just break it down into two. You think of it as the bank firstly gives you some amount of money, and then at some interest. So they're sort of investing in you, all right? So you're gonna give them interest, and then we calculate that. That gives us a value of 1.1 million rents, okay? And then on the other side, we thinking of it as how much would equal payments of 9,018 rands for 50 months at interest of 18% per annum compounded monthly would yield after these 50 months. Okay, so now we're seeing that would amount to 664,000. So the balance obviously would be the difference between those two values. Okay, so now that's what we got. That's the balance at the end of 50 months. Okay, our last question is as follows. We are told that Leago Holiday Resort bought a pleasure boat with a value of 4,500,000 rands. The value of the boat depreciates at 11% per annum using the reducing balance method. The price of a new boat increases by 8% annually. The resort plans to replace the boat after 6 years with the aid of a sinking fund. Okay. All right. So the first question is determine the value of the existing boat after 6 years, and also determine the value of the new similar boat after 6 years. Okay, so understanding this, the resort buys a boat for 4.5 million rands. Okay, and then that boat depreciates obviously with time, and then again on the other side, the value of the new boat increases with time. Okay, so now the first question, determine the value of the existing boat after 6 years. So we are told that this boat reduces on the reducing balance method. So this is what we know about the reducing balance as explained in the basics. So this is the first question. So that's going to be P1 minus I to the N. So this basically means it's reducing on a compound scale. You see, so now they want us to find the value. So obviously it's starting with 4.5 million rands. That's your principal amount. 1 minus I, your I is per annum, so that's just going to be 11 over 100. And then after how many years? After 6 years. Okay, so you find out how much will it be worth at that time. So that's 4. Oh my god, baby. Calculated diet and hlaza when I'm lele. Anyway. Okay, so that's gonna be 4500 4500 1 2 3 to 1 minus 11 over 100 all to the power of 6. All right, so after 6 years, the boat will be worth 2,230,000 36,415 rands and 81 cents. That's what the boat would be worth at the end of 6 years. Okay, so the second part, they're asking determine the value of the new similar boat after 6 years, and then we're told that the price of a new boat increases 8% annually. It doesn't care what happens. Every single year it increases annually by 6%. What does that makes us to think of? Simple interest. So this is a simple interest. So this now becomes P into 1 plus IN. All right. So how much will it be worth after 6? How much will it cost after 6 years? So currently it's 4.5 million rands, and then into 1 plus your interest is that's 8 over 100 multiplied by number of years, that's 6. So this is gonna be worth 8 by 6, and then this is gonna be worth 6,660,000 rands. Yes, just like that, 6,660,000 rands. So just a quick recap: the old boat is going to depreciate after 6 years from 4.5 to 2.2 million. The new boat, the price is going to increase from 4.5 to 6.6 million in 6 years. Okay, so our very last question says determine the value of the sinking fund and the monthly installment to achieve the amount, which is the same amount of sinking fund at 10% per annum compounded monthly. All right, so we know that the resort has bought a boat which loses value, and then they went to replace it at the end of 6 years by a new boat which would have increased in value. We have found those values, so we know that the new price was 6,660,000 rands, and then the existing boat has decreased to 2,236,000 and then 415 rands and 81 cents. Okay, so this is the new, this is the existing. So we need to find the value of the sinking fund. So basically what they're asking, how much should we save up such that at the end of 6 years, when we sell the old boat and we want to buy the new boat, how much money is required? So this can easily be calculated from this. So the sinking fund would be I'll just say the scrap value, right, minus the new price. Okay, so this is gonna happen. They're gonna sell. Okay, this is actually the other way around. So it's the new price because we want to buy a new boat at the end of 6 years, a new price minus, then we're selling the old one, minus the scrap value, that's the depreciated value. Okay, so the new price, we found it to be 6660 and 000, and that would be the minus the scrap value of 2,236,415.81. Okay, so we can calculate that. So that's 666,000 minus 2,236,415.81. So this is how much they need to have in their sinking fund, which is 423 584.19. So that's 4,423,584 rands and 19 cents. So that's the value of the sinking fund. Okay, so now how much should they put every month for 6 years to make sure that at the end of 6 years they would have saved this much value to replace the new boat, to replace the old boat with the new boat? So to find that value, so that's the monthly installment. So we can see this is a future value annuity. We want to know how much money should we put in now such that later on in the future we can have this amount. So this can be calculated this way. That's x 1 plus I to the n minus 1 all over I, right? So I'll just write this here. So that's our value, 4,423,584.19, and then that's equal to our x, which is what we're looking for, and then here we have 1 plus our I is 10%. So that's, I've just fast forwarded the whole thing to the final answer, but I'll walk you through what I did. So as we were here, so now we're still using the same formula. So what happened is we're looking for our x, which is our monthly installment, and then we have this, which 4.4 million, which we are equating to the whole formula, and then our interest is 10%, which is 10 over 100 multiplied by 12. By the 12 is to take note of the compounding, yes, and then all that is raised to 6 years multiplied by 12 to convert the number of years to the number of months, and then minus 1 all over I. So that gives us 45,087 rands. Okay, so I hope everyone can get here. This is just one formula. This is just one formula. Let it not confuse you. It's just one formula, and then we're solving for x. So I cross multiply this by that, and then after I divide it by what is in this bracket, so that I can find the value of x. So I got it to be 45,000 rands. So this means that 45,000 rands would have to be contributed to today's investment for 6 years every single month, such that at the end of 6 years we would have saved, well, they would have saved 4.4 million rands. When you add 4.4 million rands to the 2.2 million rands of the scrap value, or the value, the depreciated value of the current boat, that would give them 6.6 million rands, which is the price of the new boat. I hope this makes sense. So I've covered sinking fund, I've covered present value, future value annuities, I've covered, I think, pretty much everything for financial math. So I know this financial math is perceived to be quite difficult, and honestly it's not. Maybe it's just a matter of how the question is asked and then how to make use of the information that's given, but I hope we have clarified that, and then we also have learned a lot from these videos. So I would like to ask you to subscribe to our channel and like this video, and then if you want to interact more with us, you can find us on our Facebook page, which you will find the name in the description. All right, thank you. Cheers.